Okay, next rule. X squared to the fourth power. This is often termed as raising a power to a power. You will sometimes hear me say powers in and out, okay? But raising a power to a power, powers in and out. But again, a power means the same thing. So this 4, first of all, means I have x squared 4 times. So the 4 on the outside means I have 4 of the things that are on the inside. It means x squared times x squared times x squared times x squared. And then we know that each of those x squareds means x times 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 x. And if I count them all up, there's 8 of them. X to the 8th power. So again, if you're stuck on assessment and you're like, okay, I don't know which rule to use here. Sometimes, like you can be going along and all of a sudden you get confused. Think about long ways, what the rule means. What a power means is it tells you how many times something's being multiplied. So if you had to, make a simple version of the question on, off to the side on a piece of scrap paper and remember the rule that way. But, as I said, we would never do this. We would never want to do this. If these powers were like 32 and 48, oh my God, we'd be writing till the end of the period. Okay? We don't want to do that. So we can see pretty simply that now we're going to multiply the powers. So when I have a base to a power, raised to a power, I multiply them together. That's my rule. Now, the part this is where teaching you one thing, there are 2 different things I can teach you on how to do these questions with the coefficients, okay? So I'm going to throw it out there that you can simplify what I'm doing for sure. I want to show you this because when we get to negative exponents, we don't get those this chapter. We get those when we divide later on. When we get to negative powers, this is kind of important to understand this part of it. Right now, it probably is not going to have a great effect, but I'm going to go ahead and show it to you now. Okay? Okay, so what does the power of 2 mean? It means that I have that thing on the inside 2 times. When there's not a power on a number or a variable, it has an understood 1. Okay, so this is my extra step I'm throwing in. So I'm going to have 3 to the 1 times 2 and x to the 3 times 2. So even when there's numbers, this is a base, has an understood 1, so that power goes with the 3, that power goes with the x. Okay? Then I simplify that, and I get negative 9x to the 6th. The negative is not part of the squaring, just the 3 is being squared. That's why it's still negative. You would not need to write this. You certainly could just go 3 squared is 9, 3 times 2 is 6. So I don't need to see this written. That's the part I'm talking about where I'm kind of throwing in an extra step right now.
But isn't 3x to the 3rd? I thought isn't it just 1 variable?
Yes, but the power would go to, the power still goes to everything though. So this power here is only on the x, that power of 3, but this power means it's all of that. So it means, like long ways, I could write it out as 3x to the 3rd times 3x to the 3rd. Because it means 2 of these whole things, which is why you take the power to everything, the 3 and the x.
If it was 2 of them, would it be positive?
Say that again? Never mind, I heard you. See how the negative's on the outside?
Yeah.
Okay? This is not part of that power. This power only goes to this stuff. This is why it's negative.
Because it's only 1 term.
I'm coming over here now. It might answer the question or make it more clear. So on this next question, which almost looks like the question I did, this has an understood 1. So I'm going to have negative 3 to the 1 times 2 power, x to the 6th power, that one is going to be a positive answer. Because here, the power goes to the negative also, because it's in the parentheses. Here, the power didn't go to the negative. It only went to the 3 and the x. So this negative just comes down. And then I square the 3 and get my 9. This one, I'm squaring negative 3. I'm taking negative 3 times negative 3. So two different things. And then somewhat similarly is the next question, where the 2 doesn't go to the 3 at all. So that's going to be just negative 3 comes down, and then on my x, 3 times 2 is 6. So you can see why what I'm talking about, where the rule is simple. I mean, if I multiply the powers, do I add the powers? But knowing how to do it correctly. Okay, on this next one, understood 1 on that 7. So I have negative 7 to the 3rd power, 1 times 3. X to the 9th, 3 times 3. Y to the 6th, 2 times 3. And then go ahead and calculate negative 7 to the 3rd. Make sure that you use parentheses. 1 times 7 is 49 times 7 is 243. 343. So negative 343. X to the 9th, y to the 6th. Negative 7 times negative 7 times negative 7. Here I'm multiplying, but first and foremost, I have powers on those parentheses, so that has to happen first. So I'm going to have 2 to the 3rd, x to the 3rd, 9 to the 2nd, x to the 2nd. Because all of these powers on the insides of the parentheses are understood ones. I'm just going 1 times 3, 1 times 3, 1 times 2, 1 times 2. And again, if you automatically make this 8 and you automatically make that 81, please do so. Okay? I want to make sure you can and know you can do that, but I want to make sure I show you that because of negative powers later on. Okay? So I'm going to have 8 x to the 3rd times 81x squared, and I get 648 x to the 5th power now. So now I'm multiplying, there I'm going to add them. But once they all start getting mixed together, that's when you really got to know them. Okay, the next one's, kind of similar, just bigger. So I'm going to have 2 to the 5th. If you make that 32 right away, that's fine. X to the 3 times 5, y to the 2 times 5. Okay, Jack, I'm going to pick on you for a second because you were asking. So look at this next question. Does the negative go to the power also? Because? Because it's, I'm looking for something else. Because it's located where? In the parentheses. Good. Okay, so then, Jack, I'll just keep asking you, is it going to come up positive or negative? Because? Okay, perfect. Exponent's even, so it's going to come up positive. So now we can ignore the negative. And then 1 times 8 is 8. 3 times 8 is 24. Then I put it all together and I have 2 to the 5th is 32. X to the 15 plus 8 now, 23. Y to the 10 plus 24, 34. Some questions before I go to the next one? There's a couple different ways to do this question. I personally would work from the inside out, but you could kind of work from the outside in on this one too. I like going from the inside out better first. So I'm going to ignore first this 4. I'm not even going to act like it's there, and I'm going to do the inside of the brackets. Oops. So I'm going to get 2 to the 3rd, x to the 6th. So 1 times 3, 2 times 3. Now the 4 is still there, we just imagined it wasn't. And then that's going to give me 2 to the 12th, x to the 24th. And then I would want you to calculate that. Is it 4,096? X to the 24th. I didn't do that in my head, it's just a memorized fact. I don't calculate that quickly.
Wait, you just remember that stuff?
I just like knowing your multiplication facts. When you do things, when you do math things a lot, they just there, they're just stuck there forever. Forever. Okay, so my next one. I have a fraction. I don't like fractions, but order of operations would be important on this one. You have to simplify each factor before you can multiply them, because the powers come first. So this is going to be 1/3 to the 2nd, x to the 8th, and then 6 to the 3rd, x to the 9th. So that power, so 1/3 squared, and if you made that 1/9 right away, that's great. 6 to the 3rd, and if you made that, I think it's 2/16 right away, that's fine. So then I have 1/3 squared is 1/9. And, you know, really, you could punch into your calculator 1/3 squared times 6 to the 3rd. 1/3, yeah, I said that right. Is that 2/16? That's not right. So 2/16 x to the 9th. So 1/9 times 2/16 is 24. X is 17. Add the powers at that point. These aren't quite as quick as the first ones. Jack.
I got 32 x to the 17. I put 2x to the 5th, x to the 17th.
What did you get, 36? Did you say 36?
32.
You got 32? Did you do these separate?
Well, I got rid of the 1/3.
First?
Yeah.
Okay, you can't do that. You have to square the 1/3 first and cube the 6 first,
Yeah.
then put them together.
I did that. I got 1/3 squared x to the 8th times 6 to the 3rd x to the 8th.
Okay, then,
I got 2 to the 5th x to the 7th.
okay, you gotta actually square it. You gotta make this 1/9 first and 2/16 first. You can't cancel quite yet there. So you're canceling 1/3 with 6 before you're doing your power.
We can't do that.
No, you have to do that power first. Because what would you, like if you canceled that, what would you do those powers hanging up there? 1's a 2, 1's a 3. Okay, so exponents are gonna come before multiplication. So we gotta simplify your 1/3 squared and your 6 to the 3rd first. Is that the